analog to digital interface. ADC or analog to digital converter interfacing with the microprocessor. We're going to see the analog to digital converter is an input device to the microprocessor and is interfaced with the microprocessor using ports of 8255. Microprocessor sends an initializing signal to the analog to digital converter to start the analog to digital conversion process. The start of conversion signal is a pulse of a specific duration. Two popularly known conversion techniques are successive approximation technique and dual slope integration technique. Successive approximation technique is one of the fast communication technique for ADC conversion. The conversion delay is 100 microseconds at a clock frequency of 640 kHz. The general algorithm for analog to digital conversion interfacing contains 4 steps. The first one is applying the stable analog input to ADC using sample and hold circuit. Second step is to apply start of conversion, that is SOC signal pulse by the microprocessor to the ADC. And the third step is to read the end of conversion, that is EOC pulse by the microprocessor. And the last one is the read digital data output by the ADC at the microprocessor. The figure shows the block diagram of the analog to digital conversion process. This ADC is a 8-chip CMOS. It is very fastest and the conversion time is 100 microseconds. The internal circuits perform 0 scale adjustment or even full scale adjustments. 8 channels can be used, but only one can be selected at a time using the address lines called add A, add B or add C. It uses 8-bit successive approximation technique and it eliminates the need for external 0 and full scale adjustment. As we are seeing in the diagram, this 8-channel analog multiplexer has 8 number of inputs, namely input 0, input 1 up to input 7 and 3 address lines, namely A, B, C for selecting the analog input. This is connected to the control and the timing unit and register ladder switch tree. Both are connected to the output latch, which has the 8-bit output lines. And the figure shows the interfacing of ADC with 8086. It uses port A of 8255 for transferring digital data output of ADC to the microprocessor and port C for control signals. The analog input present in input 2 of the ADC and the clock input of suitable control signals. The analog input 2 is used and therefore address pins ABC should be 0, 1, 2 respectively to select input 2. The output enable and address latch enable pins are already kept at plus 5 volt. The output enable and address latch enable pins are already kept at plus 5 volt to select the ADC and enable the outputs. Port C upper act as the input port to receive the end of conversion signal, while port C lower act as the output port to send start of conversion to the ADC. And this diagram shows the interfacing of ADC with the 8086. Here the conversion delay is the term which is used to define the time taken by the converter to calculate the equivalent data output from the instant of the start of conversion. You can see reset, input output read, input output write, A1 A2 address lines, D0 to D7 data lines and port A PA0 to PA7 port B, PB0 to PB2, and port 7, PC0 to PC7. It is 8255 is interfaced with the analog to digital converter 0808, and the start of conversion signal is being given to indicate the analog to digital conversion is being started. After the process is completed, the end of conversion signal is generated. This shows the program for the analog to digital conversion interface with microprocessor. And the next topic is digital to analog interface, that is DAC interface. Interfacing digital to analog converter with the microprocessor. It converts the binary number into their equivalent voltages. The digital to analog converter find applications in areas like digitally controlled gains, motor speed controls, programmable gain amplifiers, etc. This IC1408 is an 8-bit or to 2 or ladder type DA converter compatible with TTL and CMOS logic. It is designed to use where the output current is linear product of an 8-bit digital word. The techniques employed for DAC technique is weighted resistor network or to 2 or ladder network current output DA converter. The DAC applications areas are mentioned as the motor speed control, etc. And the characteristics includes resolution and settling time. Resolution is defined in two different ways. One way is to define the number of different analog output values that can be provided by a DAC. And secondly, the resolution is may also be defined as the ratio of a change in output voltage resulting from change of one LSB at the digital inputs. And the settling time is the time required for the digital to analog converter to settle for a full scale code change. Another term is then accuracy. It is a comparison of actual output voltage with expected output. It is expressed in percentage. Some of the features of DAC are listed below. It is a monolithic 8-bit DAC manufactured by National Semiconductor. It has settling time of 100 milliseconds. It can operate on a range of power supply voltage from 4.5 to 18 volt. The resolution of the DAC is 39 millivolt approximately. It is a 16-bit IC where we can see the pins are in-out voltage, I-out, VLC, and B0 to B7, V plus, reference voltages and compensation. Figure shows the interfacing of DAC 0800 to the microprocessor. We have 8255 interfacing and 0800 DAC. In 8255 already we have seen what are all the parts and how it is working. So port A, 8-bit port lines are used to interface 8255 with the DAC by using 8 pins of A1 to A8 of DAC, and it has VCC power supply I out. It is given to the IC741 op amp, which produces the analog output voltage. In this way, the digital signals are converted into analog voltage and it is made available at the output of operational amplifier.